All right, let's go ahead and get started. Welcome to our webinar, everyone. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to cover a breakdown of regression models, how to interpret them, how to set them up, what types of assumptions to check. My colleague, Brittany, is also assisting today, and she's providing some hyperlinks in the chat box if you have any questions about the services that we provide at Statistics Solutions. And if you have any questions, you can type them into the chat box yourself, and you can even put them in the Q&A box. At the end of the webinar, I will be doing a Q&A session to address any questions. And we will be sending everyone a copy of the PowerPoint, as well as a copy of the webinar. All right, so I'll give a brief overview of the services that we provide at our company. Then we will dive into today's topic to discuss regression models. And then I'll give a brief demonstration in our Intellectus statistics software, which is a great software that can crunch numbers for you. It can clean data, and it can provide an APA write-up for you automatically. And then we'll conclude with a summary and a Q&A session. So on this slide, you can see all the different components of the dissertation that we assist with. We start with topic development and go all the way to proposal and final defenses. So the way our company works is we assign both methodologists to you and a literature review specialist. Depending on where you need assistance, you may receive one specialist or multiple. And we assist with both quantitative and qualitative studies. So if you've hit a roadblock and you need help framing your research question, finding a theoretical framework that will encompass your study, finding articles to support your topic, figuring out your research design, surveys, instrumentation, what is the best analysis you need to run to address your questions, we can help with all of these components. We also have a SurveyMonkey account, so we can help host a survey for you, and we assist with the crunching of the numbers and presentation of the analysis. And once you've completed your dissertation and you are interested in potentially submitting to a journal, we can help condense your dissertation into a journal publication. So if you have any questions about these services, you can give us a call at 727-442-4290. So the first foundational topic we should discuss regarding regressions is level of measurement. This is really important because the level of measurement that you use for your variables of interest is going to help the decision in terms of what regression model you use. So there are three key types of variables. We have continuous, we have nominal, and we have ordinal variables. Continuous variables are variables that fall on a scale or a continuum. Examples of these include test scores, SAT scores, ACT scores, or just a high school math test. It's usually 1 to 100 or 0 to 100. So that is a continuous variable. Temperature, weight, height, BMI, composite scores on a validated instrument. For example, if you're using the MLQ or the job satisfaction survey, usually you take an average of a series of survey items or a sum of survey items. And if they are Likert scale, once you've taken a sum or an average, that resulting variable is considered continuous because you could have decimals as a possibility. If you see a decimal as a value, it's usually continuous. Nominal variables are categorical variables. So there's no intrinsic order to these. We have gender, ethnicity, passing and failing of an exam. These are all categorical variables. Ordinal variables are a subset of nominal variables. However, they have a natural ranking or an order to them. Examples of these include education. If education is a multiple choice response,
Hey everyone, it looks like we're having some technical difficulties. There was a massive storm and Justin's internet did go out. We're going to see if we can get it back on here in the next couple of minutes. Go ahead and fill in your questions if you have any right now. Again, we do have a previous version of this webinar on the archive if we aren't able to get this back up, and we can host it again at another time. Just give me a few minutes and hopefully we can get this figured out. Thank you for your patience.
All right, I think I'm back. Brittany, can you hear me okay?
Yes, I can hear you. Perfect.
Okay, excellent. Okay, my apologies, everyone. There's a massive storm outside my office. I think the Wi-Fi just dropped. But let me share my screen and let's go ahead and continue here. Hopefully it doesn't happen again. But if it does, we will reschedule this webinar and we'll do it again. So I think we were previously discussing the levels of measurement, and based on the dependent variable that is in your study, you can then decide what type of regression model to use. Now, just to lay the foundation, you own a regression model when you're trying to predict an outcome. So it's when you have a series of predictors or independent variables and you're trying to predict a criterion or dependent variable. It's different than a correlation. A correlation is looking at a two-way association. There's no independent and dependent variable. A regression has prediction. So you have independent and dependent variables. So a linear regression, probably the most common approach that is used, is applied when you have a continuous dependent variable. So if you're predicting something like test scores or temperature or weight, then that is going to be a linear regression. Then we have categorical type of regressions. So if you have a binary logistic regression, you see the word binary, which means two. That means you have a dichotomous or a binary outcome. So something like test scores, if you're trying to predict someone passes or fails a test or an exam, then you would do a binary logistic regression. A multinomial logistic regression is used when you have a categorical outcome with 3 or more possibilities. So it's taking the binary idea and generalizing it to more possibilities. So if your outcome was ethnicity, white, Asian, Black, Hispanic, something like that, then you could use a multinomial logistic regression. And then the final component is an ordinal logistic regression. This is used when you're trying to predict an ordinal dependent variable. So something like education, or if you're predicting a single Likert scale item on a survey, that is when you run an ordinal logistic regression. Okay. So that's really, I would say, where it trips up the most for a lot of statisticians and people trying to run stats. This is the big decision right here. What type of regression do I run? Once you understand continuous, nominal, and ordinal, the same definitions apply to the predictors, your independent variables. So again, I've provided the definitions of these here. The predictors in your regression model can be any level of measurement. They can be continuous, nominal, ordinal. You can have one predictor, you can have a combination of these. There's no real limitation. But there are things to keep in mind when you put these predictors into a model in SPSS or Stata or so when you have a continuous predictor, you actually don't need to do anything. You just put in a continuous predictor as it is. When you have a dichotomous predictor, or if you had gender as just male and female, you want to code specifically for passing and failing an exam. If it's something like someone has a condition or they do not have a condition, then you code the absence of the condition as a 0, and you code the presence of the condition as a 1. Passing would be a 1 and failing would be a 0. If you have a nominal variable, ordinal variable, and you're trying to include it as a predictor, you have to follow a process called dummy coding. So there's a lot of articles on this. I won't be able to go too in depth. And basically, if you have a categorical variable, you can't just input ethnicity into a regression model. You have to dummy code the variable, because a statistics software doesn't understand 2 is Black, 3 is Asian. We have assigned meaning to this variable. And the way we do that is by creating a series of binary variables. So what you do is you pick a reference group. Among these different ethnicities, you pick one of these groups to be your reference, and then every other category is going to be compared to that reference. In most studies, when you're looking at ethnicity, the white ethnicity is treated as the reference because it tends to be the most prevalent. So you would we have 5 possibilities here, right? We have white, Black, Asian, Hispanic, other. You would create 4 dummy variables. One would be Black versus white, one would be Asian versus white, one would be Hispanic versus white, and the last would be other versus white. So then you have a series of variables just coded 1 and 0. So 1 would be Black, 0 would be white. This is the way you can mathematically and statistically look at categorical predictors. The next thing you do with almost any statistical analysis is you have to verify assumptions. So there are many resources that you can do that, or where you can figure out what assumptions should you check. So you can go to Statistics Layered. That's a pretty good website. You go to Statistics Layered. I see a lot of universities like Statistics Layered as references now. So if you put Statistics Layered Regression, and say we're doing a multiple linear regression, and if you scroll down, you can see all the different assumptions you should check before you run the regression. Okay, so things, depending on what resource you read, you might see very different assumptions listed. This one, I think Statistics Layered, they go a little bit overboard. They have what here 8 different assumptions to check. Personally, I don't think all of these are of utmost importance. Some of them are just definitions. Your dependent variable should be continuous. I wouldn't even call that an assumption. I think that's just a definition of a linear regression. But yeah, that's important that your dependent variable is continuous. Your independent variables can be multiple different types of measurements. You can have 2 or more. If you're doing a multiple regression, you need to have at least 2 predictors. There's independence of observations. You have a linear relationship between your predictor and your outcome. Homoscedasticity, multicollinearity, no outliers. So a lot of these are important, but they aren't necessarily things you have to check for a regression. No significant outliers. That's probably something you should check at the very beginning before you even run the regression, that there are no outliers in the data set, because that might skew your findings. So yeah, I tend to check for normality. So normality right here, I'll do outliers at the very beginning. Multicollinearity is important. Homoscedasticity is important. Those are the key 3 or 4 assumptions I tend to do. Okay. The linear regressions have many assumptions, as I just showed, but when you do logistic regressions where you have a categorical outcome, there are not as many stringent assumptions to check. Something to keep in mind. And then what are the steps for interpretation? Okay, we'll go through this using an example. I have a sample spreadsheet, but the first thing you want to do is interpret your omnibus test. And that is the F test if you're doing a linear regression, and it's a chi-square test if you're doing a logistic regression. And what this does is it tells you the collective strength, the collective predictive strength of your model. And with almost all statistics, we evaluate significance if your p-value is lower than 0.05. The second thing to look at is the coefficient of determination. That is either an R-squared for a linear regression or McFadden's R-squared for a logistic regression. Sometimes I see a Nagle-Kirky R-squared for this one, for a logistic regression. That is just as valid. And then the third step is interpreting each predictor in your model. Okay, so this step 3 is contingent on step 1 being significant. So if you don't have a significant model collectively, you don't typically interpret individual predictors on their own. If step 1 is not significant, you kind of just stop right there. Okay, so you'll interpret individual predictors with the t-test. For a linear regression, and for a logistic regression, you do a wall test. Okay, so let's take a look at Intellectus here. And this is what Intellectus looks like. You can upload a data set, and there are different formats. You can upload a CSV, Excel, SPSS, SAS, or Stata. And once you've done that, you can see this is what the data set looks like. This is just a sample spreadsheet that I downloaded. And what it contains are different car models. You can see a Mazda, Mercury, Chrysler, Toyota. In the spreadsheet, it's measuring different components of the car. What is the mileage? What is the horsepower? How many cylinders does it have? So just to give an understanding of nominal, ordinal, continuous, you can see values that are numeric, that are like a hard count of a number. Those are continuous. Scale is a synonym for continuous. It means the same thing. We have an ordinal variable here. So here's a good comparison of a continuous mileage. Here we can see the actual mileage, miles per gallon. And then to the right of it, this is an ordinal representation of mileage. 10.4 falls between 10 and 15. So it's kind of like if this was a multiple choice response, 10 to 15, 15 to 20, 20 to 25, it's different ranges, but not a specific value. So this is ordinal. And then we have nominal. So nominal is if you have categories, things that are non-numeric. So what type of engine does the car have? Is it V-shaped or straight? Does it have an automatic transmission or a manual transmission? Okay, and within Intellectus, you can see that you can clean the data, you can recode variables, you can reverse code, which is frequently used if you have negatively phrased items and you're using a Likert scale survey. We have imputation, which can be used to replace missing values in a spreadsheet. You can remove outliers, you can create variables of interest using the variable calculator, and you can transform data. You know, if you check for the normality assumption and it is violated, you can potentially transform your data to a different variation, and that can fix the normality assumption. And then we have plots. You know, you can do scatter plots, you can do profile plots. And then under the analyses, you can see all the different analyses that you can do. We're focusing on regressions today, but say you're not even at the data step, but you want to know more about regressions, you can go to the data analysis plans right here, go to regressions and a linear regression. And Intellectus is going to provide a sample write-up for you that explains what does a hypothetical research question look like for a linear regression, and what is the interpretation. Now, this is more methodology information, stuff that would go in your data analysis plan before you collect data. And then it talks about what assumptions will be verified, of the F-test and the R-square. In addition to that, we also have power analyses, which are used to determine the minimum sample size that you should target. And when we generated this write-up for Intellectus, we use G-power to verify the findings. G-power is used for power analyses. So you can see here for regressions, a linear regression, the sample write-up gives a power analysis if you have one predictor. If you have one predictor and a large effect size, you should target 25 people. If you had a medium effect size, 55 people. And if you had a small effect size, it skyrockets to 395 people. If you don't have literature to tell you what effect size to use, always go with the medium effect size. It's the most conservative. But the number of people that you need, or the number of subjects you need, it increases based on how many predictors you have. So you can see we only have hypothetically one predictor, but at the top left here, I can change how many predictors are going into the model. So say I added 7 predictors altogether. Now a medium effect size requires 103 participants. If I go to 9, it goes to 114 participants. Okay, and then for a logistic regression, you can see here that the same logic applies. You need more people for a logistic regression. I've even seen rules of thumbs being used. I have a sample write-up of that here somewhere. Let's see. Logistic regression sample size. So logistic regression is a little bit different. If you don't run a power analysis, you can say it's based on how many predictors you have. So this reference says that 10 participants per predictor are ideal, but 20 is preferred. And then this person has a more stringent requirement. So they say a minimum of 30 participants per predictor. So you just need to go with whatever citation you use and justify it. I've seen between 10 and 30. Okay, so let's go ahead and run some hypothetical regressions here. What we can do first is a linear regression. And let's see if the research question is, does the weight of a car, and this is in metric tons, so I guess 2,000 pounds times whatever number is in here is the weight in pounds, and the number of cylinders. Let's see if weight in cylinders predicts the mileage of the car. Okay, so we'll go to analyses and then linear regression. First, you have to select your dependent variable. So what are you trying to predict? And that would be miles per gallon, which is mileage. Then you select your predictors, your independents, and in this example, we'll do weight and we'll do cylinders. Then at the top right here, you can see options, and there are a list of different assumptions you can check. And Intellectus is automatically going to provide an interpretation for these in a write-up. So in general, I keep normality enabled, homoscedasticity enabled, and variance inflation factors. This is for absence of multicollinearity. So we'll save the options and then click calculate. And in just 5 to 10 seconds, it's going to give you a full write-up on that regression. So this research question pretty much addressed in full. The first thing it does is it goes through the assumptions, and it's going to check for normality using a QQ scatter plot. And if you hover your mouse over the figure, you can see what is ideal for this assumption and what is not so ideal. Hopefully it looks like the top left, or it approaches what is in the top left quadrant right here, which would be the data closely following this diagonal trend line, which it does fairly closely. I would say a limitation of the spreadsheet is the sample size is quite small. We only have 32 different car models, which isn't a large sample size, but you can still run analyses on these and it's going to be interpretable. Then homoscedasticity. This is making sure that we have random scatter and random spread in the responses. And you just want to see a non-recurring pattern in this one, which we do. And then multicollinearities, making sure that the predictors are not highly associated with one another. So weight is not strongly correlated to number of cylinders. And to interpret this, we use variance inflation factors. Ideally, these values are below 10. Okay, and these are both below 10, meaning that the assumption is supported. Then we go into the interpretation. Okay. And coming back to the PowerPoint, the first thing you do is you look at the F-test. We're doing a linear regression, so we're going to look at the F-test. And that is at the very bottom here. You can read the narrative, but I think the table really summarizes everything that you need. And the F-test is at the bottom here, and it is significant. So that means that weight, the weight of the car and the number of cylinders does predict mileage collectively. Then we look at the R squared value next, right here. And that is right next to it, 0.83. So you can convert this to a percentage by moving the decimal over right twice, meaning that 83% of the variance in mileage can be explained by weight and number of cylinders. And then the final component, remember step 3 is only done if you have a significant F-test. We did prove that we have a significant F-test. So this gives us the ability to go inside the table now and interpret each predictor on its own. Okay, so weight, you can disregard intercept. That's just part of the APA format of what it's reporting. It's not highly interpretable. But we look at weight and we go all the way across to the right. And weight on its own is a significant predictor. Then you interpret, in this example, the beta value. So you look at two things. You look at the sign of this beta value, and then you look at the actual value. So what a significant weight predictor means is that as weight increases by 1 unit, meaning as we increase the weight of a car by 1 metric ton, the mileage of the car tends to decrease by 3 miles per gallon. Okay, so as this value increases by 1, what happens to mileage? Same with cylinders. Cylinders is also a significant predictor. And you follow the same logic. As the number of cylinders on a car model increases by 1, the mileage tends to decrease by 1.51 miles per gallon. which both of these, that's intuitive. You know, the heavier your car is, the lower the mileage will be. The more cylinders you have in your car, the lower the mileage is going to be. Okay, so that's a linear regression. We can also do a binary logistic regression. So remember, to do a binary logistic regression, you have to have a binary or dichotomous outcome. So that would be something like transmission type or engine type. Let's do transmission type and do a similar analysis. How does mileage and horsepower predict what transmission type of car is? We go to analyses and then binary logistic regression. Dependent variable will be transmission. Then you have to pick a reference group. So usually similar to like passing and failing an exam, as I explained earlier, 0 will be fail, 1 will be pass. In this case, this is assuming automatic is coded 0 and manual is coded 1. And then we'll go to independent variables and select mileage and horsepower. And you can see options at the top right here. There is significantly less to check in terms of assumptions. We only have variance inflation factors, which is for the multicollinearity assumption, but everything else is not here because logistic regressions are not considered parametric analyses. So it doesn't have stringent assumptions to check. Then we'll click calculate. And we'll have the write-up over here. You can see we have a table of contents. You can shift things around. Say I wanted the binary to come before the linear regression. That's how you maneuver. So we can see first, a similar assumption as we checked before, absence of multicollinearity. Mileage is not significantly or highly related to horsepower, given that the VIFs are below 10. Then we come down here, and just like the linear regression, the first thing you do is look at the omnibus test, which we talked about here for a chi-square. It's going to be a chi-square for this logistic regression. And you look at the p-value, which is oh so significant. And I should have mentioned, if you hover your mouse over terms, it tells you what they mean. So we have a significant p-value because this is below 0.05. And then we look at the coefficient of determination next. In this case, a McFadden's R squared, which is right next to it, right here. So this means 56% of the variance or the change in transmission type can be explained by mileage and horsepower. Then we interpret each predictor on its own. So we look at mileage first, go all the way across to the p-value. This is a significant p-value because it's below 0.05. Then, unlike the linear regression where you interpret the betas, you interpret the odds ratio. That for this. So what this means is that with every 1 mile increase per gallon, the odds of having a manual transmission car increase by 252%. Okay, so it's just subtracting 1 from this and then moving the decimal over right twice. Okay, so that's where the 252% comes from. You could also say that with every 1 mile increase in a car, the odds of being a manual car are 3.5 times more likely than an automatic car. There are multiple ways to phrase it. Similar with horsepower, we do have a significant p-value for horsepower. With every 1 unit increase in horsepower, there is a 6%, about a 6% better odds of having a manual transmission car. Okay, and that's the interpretation, just 3 steps. All right, so in conclusion, you run a regression when you're trying to predict an outcome, determine what's the best approach based on your dependent variable and what the level of measurement is for that dependent variable. Then check for your statistical assumptions. Linear regressions have far more than logistic regressions. You can use a website like Statistics Layered I'll put that link in the chat box just in case. And this website can be used to check what assumptions to check. Then you can follow the 3 steps for interpretation on a regression model, and you can use Intellectus statistics to analyze and interpret your data. And we also do assist at our company with SPSS and Stata. So if you have any questions and you need help crunching the numbers, just let us know. I'll now open the panel to questions. If we do have any, you can type those in the chat box. I'm not sure if I missed any questions before I left or before my Wi-Fi dropped. If you wouldn't mind typing those in again, if I didn't get to your question. Okay, I see we have some hands raised. If you wouldn't mind typing them into the Q&A box or the chat box. Any questions about what type of regression to run, power for analysis, what's the minimum sample size I need to target, how to set up predictors? Okay, I'm going to unmute you, John. Just we tend not to do this because of how many people join these sessions, but the audio can lag a bit, but let's see if it works. Hey, John, can you hear me?
Yes, I can hear you. Can you hear me now?
Yeah, I can. How are you today?
Hanging there. Yeah.
Good. How can I assist? Do you have a specific question?
Yes, I want to find out if we want to contact you, we just have to call or write to Statistical Solutions, and then we shall be in touch with you.
Yes, there are actually 3 different ways. You can email us at this link. You can give us a call. And Brittany put a link in the chat box that will automatically get you on someone's calendar.
Okay. Are you with Jeannie? Janine?
Yeah, Janine works at our company. She's my manager.
Okay, okay. Because I have her email address. I'm doing multiple regression. I'm looking at stress and burnout for students studying STEM subjects as undergraduates. You know. So that's where my research is going.
Excellent.
I finished with the proposal. I'm just going through IRB. Once I overcome that, then I'll be back on track. Yeah.
Very good. Do you have a specific part where you feel you need assistance?
Yes. Once I jump that particular hurdle and I collect data, I will run. What I see is I think I like the Intellectus, as compared to SPSS, right?
Yep. Yeah. So, Intellectus is, I use both every day. I have SPSS open right now, actually, but Intellectus is much more intuitive, and it provides a full write-up for you automatically. Plus, it's cheaper. So I don't think it's even a competition. I would take Intellectus all day.
Yeah. So if I want to get Intellectus so that I can start developing some skills, by all means, I will run to you to validate it. Where do I get access to Intellectus?
With Intellectus, you can email at the same links that are provided in the PowerPoint, but you can also just go straight to the website. I'm going to put the link in the chat box right here.
Okay.
And I believe they do free trials, so you can kind of practice around with it.
Okay. Yeah. Well, I'll wait until I get my data before I go for a free trial. Otherwise, the time will run out. Yeah.
Yep. All right. Yeah, so are you using the MBI for burnout and
yes.
BSS for stress?
Yes, MBA for burnout, yes. Yeah.
Yeah, I'm really familiar with both of those. So if you do
Oh.
sign on with us, it maybe, I could work with you because I'm quite familiar with those tools.
Oh, they're fantastic. Yeah. I started using the MBA questionnaire. Yeah. Okay. That's good. Thank you very much. And it's a multiple regression I'm trying to do.
Yep, if you're doing like how do the MBI dimensions predict stress or vice versa, potentially, then yeah, multiple regression would be the.
And then the assumptions, you show some text over here with different assumptions. Is it possible for us to have access to it? Yeah, as we are working on yeah.
About the assumption check. So in Intellectus, here are the assumptions that can be verified. I don't usually check all of these. I do just a few of them. But it depends on what resource you read. Textbooks might say to check certain assumptions, and like I showed during the webinar, this website has 8 different assumptions, which I think there's too much here, but some colleges are using statistics layered now. What university do you go to?
NCU.
NCU, okay.
Yeah, I have developed my methodology using SPSS. So I think if I want to use Intellectus, I have to go back and change it to Intellectus. Is that right?
Yeah. You would have to indicate what software you're using in your methodology. So yes, you can say Intellectus, and what I can do right now is I can give you a reference for it.
Okay.
Like a citation you can put at the end of your paper right here, Intellectus statistics. Okay. I'm putting that in the chat box as well.
Okay. Intellectus outline 2022. Wow, that's very new. Yeah.
Okay. Anything else I can help you with?
No, but definitely I'll contact you.
Okay.
Like the solution to the problem. Yeah.
Yep. Sounds good. Nice speaking with you, John. Keep us posted if we can be of any assistance.
Yeah. Thank you very much.
Yep. All right. Do we have any other questions? You can raise your hand, or you can put it into the chat box. I think the audio was pretty good. So, hey, John, did you have a follow-up?
Mention, the table over here, the table 2, the intercept. You just make a cursory reference to it and say, "Oh, that is not very much."
Yeah, it's not. There are statistical meanings for this, but for the context of a research question, it's not interpreted.
Yeah, but I'm tempted to look at it mathematically. That if the variable is 0, then you have
the y-axis is on -3.
That's what I was thinking.
Yeah, sometimes in APA format, I don't even see this reported. This row is sometimes skipped altogether, and it just jumps to the predictors.
Okay. See.
Okay. All right. Do we have any other questions?
Well, I will hold the rest back, and when we start interacting, then I'll ask you more.
Okay, excellent. All right, well, thanks for joining, everyone. We're going to send everyone a copy of the webinar and the PowerPoint, and come join us for the future sessions. Have a great evening.